Hey everyone, thank you for joining. See, we have some nice participation. I think we are ready to start. So thank you for joining. In this short briefing, we would like to share some of our experience from working with the AWS team, with the Athena team, competing with Google BigQuery. How did customers perceive us? What challenges did we face during those competitive processes? And also present you with Upsolver and why it adds value to customers working on AWS. First, a bit about Upsolver. So Upsolver is based here in Israel, planning to open an office in the US later this year. We're an advanced technology partner working with customers from various segments. The kind of use cases that we work on are streaming use cases. For these use cases, the sheer volume of the data arriving at very high speed forces customers to choose a data lake architecture, choose a platform like S3, and Upsolver is a platform that completes S3. I'm also sharing a few of our reference customers. All of them joined in the last 5 months. Upsolver was an enabler for them to consume more AWS services. All of these customers are using S3. Most of them are using Athena. SimilarWeb, for example, is a company that had data on-premise, and Upsolver created their cloud data lake. Sisense, the BI company, was actually a referral from a solution architect here in Israel. So that ended very well for us at least. And the dilemma, the competitive process that we want to talk about today is BigQuery, and it's versus Athena or versus Redshift Spectrum if it's an existing Redshift user. That's the competition we usually see. And what's really interesting is that the competition will be with customers that are already working on AWS. So why are customers that are already in AWS choose to also use BigQuery in addition to AWS? In some of the cases, also choose GCP in a later stage. So let's look at the balance. On the right side, we have Amazon, and we are offering a data lake. So you have access to all your data. Your data, first of all, the data is already on S3. So it will definitely be the lower cost solution to stay within Amazon. Athena is also much cheaper than BigQuery just by paying for reading compressed data versus uncompressed data. For Google, you pay for the uncompressed. But still customers tend to choose BigQuery. And the reason is that it's much easier to start with and to work with on an ongoing basis. Instead of creating Parquet files on S3, which is a job that requires engineers and projects and a lot of time, they just do regular ETL, regular insert into a database. So getting started is easier. And also, if they need to manipulate the data, if they need to create various aggregated table from the raw data, they can just use SQL within BigQuery. And on Amazon, since they're working on S3, they need to write EMR or glue jobs or simply spin up their own Spark cluster, which would even make it harder to do. So there is a big difference on time to insight. Time to insight is a KPI Google like to mention in these kind of processes. And there is also the matter of adoption. So data-driven companies have a lot of employees. Only a portion of them are big data engineers. And big data engineers can work with Amazon, but if I'm going to take a data analyst or a data scientist, they won't be able to complete a full process on top of AWS. They will need help with coding and with integrating the various services. So what Upsolver adds into the mix is exactly the kind of things that Google are offering today. So instead of waiting for a few months to create data, Parquet data for Athena, we do it in a few minutes. I'll actually show it in a demo today. We increase adoption, so more users in the organization can use Amazon services like Athena, and eventually just by leveling the playing field, customers enjoy a much lower cost. They can stay within their AWS environment and they can see more value from the data they already have on S3. So the way we present Upsolver is a data lake platform. It works on top of S3, so Upsolver isn't the data lake, at least the data lake storage. The storage itself is S3, and Upsolver is the platform that should connect it all. So to understand Upsolver, you really need to understand the challenges. Put yourself in the seat of a data analyst or a data scientist. Imagine that you have a load of JSON, nested JSON data on S3, and how can you create insights? And there are the two parts on the bottom. Those are things that data analysts and data scientists simply can't do. They won't integrate to Kafka. They won't manage metadata in the Glue data catalog. They won't work with scheduling platforms like NiFi or Airflow. They don't know how to create Parquet data or optimize the files on S3. All of that needs to be seamless, so a data analyst and a data scientist will use S3. The top part, the data preparation part, is a challenge since they don't know when they're using S3, they use the data lake, they no longer have a database. So in order to do very simple stuff, so things for the database, it's simple. So to do aggregations, joins, to enrich their data, the kind of things they do in BigQuery using SQL, they need to code in Amazon. So to solve, Upsolver solves all of those challenges. So we enable customers to connect to the streaming sources, to create and manage a data lake on Amazon S3, and to prepare the data in any way that they want in order to feed it and then consume it in various Amazon services. The most popular we see is Athena, because that's a very data lake-like use case, and it competes directly with the S3, with BigQuery. And what we do with Athena is create a layer of Parquet data on S3, and we manage the metadata in the Glue data catalog. So a customer basically gets a managed table, all Parquet-based, and it takes them a few minutes to do. The way users are operating Upsolver is with the web application. It's a drag and drop web application, and it's simple enough so a data scientist and analyst could use it and also extend it if they want. And under the hood, Upsolver is powered by a virtual cluster. That cluster is processing the data according to what the user configured. That cluster is deployed to either Upsolver or to the customer VPC. Deploying to a customer VPC was a major milestone. Many customers with big data are very private regarding their data, especially with all the GDPR going on. And by deploying to their VPC, we solve their data privacy concerns working with the vendor. So you can see the difference. So the architecture of you when using Upsolver would be much simpler comparing to an architecture where the customer would need to do a project internally. The reason is that Upsolver is not doing something that it is impossible to implement on the AWS cloud. It will just take a while to implement the same on the AWS cloud. Upsolver combines data pipeline with data management and with a key value store, all of them packed into one software, so customers won't need to integrate the various platforms. You can get basically a single user could create, manage, and distribute data from a data lake, and that user doesn't even have to be a data engineer, and those are stories that we are seeing today with our customers, and that's the key reason you see a very big difference in the cost of ownership. So most of the cost is big data engineers. You don't need a big data engineer to manage Upsolver. Upsolver is very efficient, works more than 10 times faster comparing to Spark, so the cost of our hardware is kind of cheap. We are also utilizing spot instances, so the cost of hardware is actually very, very cheap, and the cost of software, you basically just need an Upsolver. You don't need to pay for various data platforms, and you also don't need to pay for additional capacity. Upsolver is an on-demand service. You pay for what you actually use. So an example. So it won't be too high level, and then we'll also do a demo. So in this case, we have a marketing company. They're gathering a lot of data for mobile device, and they wanted to do an anomaly detection process for that data. The data they collect, they're selling it to customers. If there is a bad partner integration, if they have a bad release, they can sell bad data to customer, which isn't acceptable. And the mobile SDK team, or at least the mobile SDK group, decided that they need analytics on top of that data. They were planning a project that was supposed to take at least a few months to do, but they managed to do it end-to-end, all using Upsolver, all in a couple of hours, and the user is actually not a big data user, it's a mobile SDK developer. So the way the data flows is starting from Kafka, an on-premise Kafka, more than 100 terabytes per month, definitely streaming data, nested JSON, more than 1,000 fields, very hard to structure this kind of data. So Upsolver is reading from their Kafka, building a data lake on top of S3 with all of the raw data, and then they actually used Upsolver to create another layer within their data lake just for what they call clean data. So the original data contained 1,000 fields, the clean data only contained 30 fields, just the one needed to create their analytics, and then they used Upsolver to also create aggregations. So tracking the unique number of visitors is the way to do their anomaly detection, and Upsolver creates the Parquet files and also manages the metadata in the Glue data catalog. Basically, the users just needed to configure Upsolver with the web application and run their SQL on top of Artena. Today, they use this data on a daily basis to improve their business. So let's take a look. How does the process work? So over here, you can see Athena, which I guess that you would recognize. And what I did here is ran a query, and I found the top 100 committers on GitHub. So the data, the streaming data I'm using is data from GitHub, what people are doing in GitHub, committing, changing code, adding files. How did I reach this table? This table is an Upsolver managed table. So you can see that the table has partition fields added by Upsolver, a schema version field also managed by Upsolver, and a partition time that enabled to do this between query. So how did I reach this table? This is the end. That will be the end result. First, I connect to Upsolver, and I need to add a source of data. So I could connect to Kinesis, for example, choose what kind of data that I want to use, choose a bucket on S3 to store all my data, and that bucket will be my data lake. After I'm going to click on create and start working, I'm going to see a data source over here in Upsolver, and these are 5 different streams I got from GitHub. This is a stream we got from Twitter, and this is the one I'm going to work on today, people committing in GitHub, 200 million events. Okay, so I'm logging into the system, and over on the left side, you can see a schema on read. So a basic concept in data lakes is you don't enforce the schema. The schema is what you actually see in the data. So this is what I actually see in the data. Last 90 days, those are the fields. This is the structure of the data. And whenever I'm going to click on a field, I'm going to see an exact, and the word exact is important here. It's very important for data scientists that usually work on samples of data. This is an exact value distribution of what's happening in my stream. I could also visualize it with a table view to understand correlation between fields. So Upsolver lets me understand what's in my stream, so I'll be able to map an output. I'm clicking on the button on the top. I'm going to click create add output. Just for the sake of time, I'm not going to review every integration that we have here. Today I'm just going to focus on Athena. So this would be GitHub commits. I said that Upsolver can work as a regular ETL, can do regular ETL, and can also be used as an aggregation engine. But in this case, I'm going to choose the first option. I clicked on next, and what you see in this page is basically all the data engineering you're going to need to do. So everything is over here. I'm going to create a table called GitHub commits. This is the database name, bucket on S3. The data is automatically going to be Parquet data. Every time we send data to Athena, we are going to use Parquet. And you could also create the partition structure, the compression, but basically after I click next, I don't really need to make any data engineering decision. In this case, in the screen that we are seeing now, I need to take my nested JSON data, so this would be the nested JSON data, the schema that we saw before, and I want to create a flat table in Athena. So I'm going to choose a few fields. If you pay attention, you can see that the value distribution is something that I see throughout the entire process. Closing the loop, seeing feedback, getting feedback on what exactly I'm going to create is a very important part in Upsolver. It helps companies understand what's actually in their data. I can also use fields that are arrays. So in this case, I'm choosing an array of repositories, and when I'm going to add that column, it's going to break down the table into a flat table. So if I'm going to click on preview, you can see that I have all the columns, and the repo name is just one repo each time. We're going to get a flat table. It's much easier for analysts and scientists to work with a flat table. So far I did some simple stuff, just added a few columns, also arrays, but I can also enrich my data. So basically for every data type within Upsolver, you have functions the same way you would find in Java. This is simple add, multiply, subtract function. If I'm going to choose string, I'm going to find some more interesting stuff. Regular expression, super popular in Upsolver. I'm actually going to do an example. I'm going to choose, again, I'm returning to the schema on read. I'm going to choose the subject field. This is what people are writing when they're actually committing in GitHub, and you can see that they're mentioning file names. And I want to collect those file names. So I'm going to use the regular expression. This regular expression returns words separated by dot. Let me show you again the design time feedback. I can preview my regular expression, see that I'm actually generating file names, decide where do I want to put this new field within my nested data, and I can also decide that I want it in my output. So this field is going to be added to my table in Athena as a new column. So that using calculated fields is a simple way to enrich and clean my data. If we would talk about SageMaker, I would talk about feature engineering and data cleansing, and for Athena, it's usually more BI use. Other options in Upsolver, very popular, at least in marketing, is generating more data from IP, so getting geographical data from IP, parsing user agent, and sometimes we also find those power users that want to extend Upsolver, and they can load user-defined functions with Python. They could also ask us, using our service, can I add the following calc field? And usually they'll see it in the system with a couple of days, but they can also decide that they don't want to talk to us and just use Python to extend the platform. That's one option. So the other option, and the very cool option, so I mentioned before that Upsolver combines data management with data pipeline, but there's also a key value store, and that's the lookup. What does it mean? I created, before this session, I created a pivot table in Upsolver. So a pivot table will have keys and aggregations. So for example, what I did is I took every committer in GitHub, used this email as a key, and added different metrics. So for example, the number of times that person committed in the last year, the number of commits per repository, so that will be a nested aggregation, very useful for profiling. Last time they committed, distinct number of repository they used. So basically, this pivot table with Upsolver enables me to join with any data source on top of S3. So for example, if I would want to join a stream of impression with a stream of clicks, I could do it with Upsolver. If I would want to create a data set and I needed different behavioral metrics, this is exactly the way I'm going to do it. And this is the best way for me to describe it is a streaming join. You can actually control the exact timing in which you'll do the join. And after I'm completing the process, clicking on save, going back, you can see that now my schema is enriched with new fields, and I can add those fields into my output as well. So I can actually do a stateful ETL process comparing to the stateless ETL process people usually do, and then they need to complete that process with platforms like BigQuery. So in this case, you can do the entire process in the upstream in the ETL and get the join data already inside Athena. One of the, let's say, the soft spot of Athena is doing a big join between two big streams. So we completely solved that within Upsolver so customers will be, it will be easier for them to use Athena. I'm going to click on run. I'm going to choose an Upsolver cluster, and over here you can notice I can start my ETL process from now on, but I can actually go from when I started collecting data or just choose any point in time on top of S3, so from S3. When I'm going to click on deploy, two things are happening right now. Upsolver is starting to create the Parquet data on S3. So this will be the link to the Parquet data on S3. And Upsolver is updating Athena through the metadata catalog. So let me just reset my resolution. I'm going to click on refresh. And you can see that the new table we just created is already in Athena. Basically a 5-minute process. I talked for 10, but if I wouldn't be lecturing, a 5-minute process to create a table on Athena based on Parquet data, working basically on any scale that you want. The 100 terabyte scale, that's exactly the process I just did. That's exactly the way that they configured it in Athena. Basically, that's it. I hope that you found this session useful. I know that we are past the time that we planned, but if you have any questions, feel free to send them in the chat and we'll start answering.